Howdy, AP Pre-Cal, it's Miss Kosh. We are continuing with these lovely multiple choice questions from Mr. Passwater. So big shout out to him. Here we go. I think we're still in the identities unit. So, okay, so here it tells us the figures show two circles centered at the origin with an angle of alpha and beta, respectively. The terminal ray of angle alpha intersects the circle at point P. Terminal ray of beta intersects a circle at point Q. The coordinates, okay, they give us the coordinates. Okay, so here's what I would probably do. I would probably off to the side write down, well, that sine of alpha is going to be equal to, well, this is a 3, 4, or 5 triangle. We know it's also 5 because they tell us here the radius is 5. But I also know my triples. So sine is going to be opposite over hypotenuse, and cosine is going to be adjacent over hypotenuse. I could write down tangent, but since they took the tangent identities out of the, well, I'll write it down just in case we see some sort of tangent problem. Nope, we're not going to, but anyway, just making me feel better. 4/3. Okay, in the past, I would teach more identities than AP Pre-Cal is requiring. So on this one, this is 12, this is 5, and this is the radius they tell us is 13, but then 5, 12, 13 is a triple. So sine of beta, right, wasn't this beta? Yes. Is going to be 5 over 13, and cosine of beta is equal to 12 over 13, and I'm not writing down tangent because they took it out of the curriculum. Okay, so sine of 2 theta, sine of 2, that's not theta, sine of 2 alpha is equal to 2 sine alpha cosine, that is an O, cosine alpha. So this is 2 times what? Sine of alpha. Well, we wrote that down, it's 4/5. What's cosine of alpha? It's 3/5. So I have 3 times 4 times 2 is 24 over 25, and there we go. One thing I see kids do every year, they'll say, oh, well, this is equal to 2, and then they'll tell me sine of 4/5, and I'm like, what? No, it's like doing something like that is saying, oh, the square root of 16 is equal to not 4, but they'll say the square root of 4. Well, no, you already took the square root. Don't do it again. So once you take sine of alpha, it's 4/5, and you're done. Okay, cosine, so this is the cosine alpha plus beta. This is the property cosine, sine, with the opposite SIGN. Okay, so what is cosine of alpha? We wrote that down, 3/5. What is cosine of beta? We wrote that down. It's 12, I can't talk. It's 12 over 13. Minus sine of alpha, we wrote that down. You can't see that I'm pointing. I can't, can you see everything now? I think you can. Okay, and then sine of beta is 5 over 13. I could try and cancel fractions, like reduce things, but we're going to have to get a common denominator anyway. So this is 36 minus 20 over 65, if I know how to do math. So 16 over 65 is that one right there. Very nice. Cosine of 2 beta, you've got 3 options on how to do this one. So maybe we'll do 2 cosine squared beta minus 1. So this is 2 times 12 over 13 squared minus 1. This would be 2 times 144 over 169 minus, well, 169 over 169. So this is 288 minus 169 over 169. I don't feel like, whatever that is. 288, is that 119? Well, it's not 120. 119 over 169, that's probably right. Pull out a calculator or do the math. I'm tired. Okay, I'm making excuses. So sine is sine, cosine, sine is how I have that memorized. And then I write out these. So this would be alpha, this would be pi over 2. And then it's the same SIGN. So sine of alpha, this was way back here, 4/5. Cosine of alpha is 3/5. Cosine of pi over 2. Cosine of pi over 2 is 0. Minus sine of pi over 2 is 1. So that's gone. This is just 3/5. Oh, maybe we should have recognized that sine, but I didn't recognize that this was an identity that lets you just shift, like the sine of, well, never mind. Let's not do that. Oh, no. Ha! Who caught my mistake before I did? It's a negative 3/5. Okay, that is wrong. No. Very good, very good problem. It would have caught me had I not slowed down a tiny bit. Okay. Well, it's a good thing to, every now and then. Okay, so which is equivalent? Well, so what do we notice? I know that sine squared plus cosine squared, or theta, whatever, is equal to that. So then I know, I see this cosine minus 1. Well, I know that sine squared of x is equal to 1 minus cosine squared. So this right here is going to be a negative sine squared of theta, and it's getting multiplied by secant of theta. So secant of theta is 1 over cosine. So it looks like it would be this, but it's not because this isn't negative. Had this been a negative, we would, oh, you couldn't see what I was doing. I'm sorry. We had a sine squared over a cosine, which is almost, had this been negative, it would have been true. Let's see what we can do. We have, this is negative sine squared times 1 over cosine of theta, which we can write as a negative. We could take one of those sines and put it over cosine, and then we could take the other sine. I forgot what I was doing halfway through. So sine times sine is sine squared, and then there's cosine here. This is tangent, and this is sine, and so this would be the correct answer. Fun. Oh, I like this one. Okay, so what we know is that when I square things, I end up with cosine squared x minus 2 times, well, sine x cosine x. And you're thinking, Miss Kosh, why did you write it in that order? Because I know what's coming. Plus the sine squared x. This is an identity. And sine squared plus cosine squared is equal to 1. And this is equal to, so it's 1 plus, no, I lied to you. It's 1 minus sine of 2x. There it is. Okay. Which of the following is equivalent to this? Okay, so back here with our Pythagorean identity, the Big Daddy, we like to nickname it, 1 minus sine squared is equal to cosine squared, so sine squared minus 1, this would be equal to a negative cosine squared over 1 minus cosine squared, which at this, on the bottom, is equal to 1 minus cosine squared is equal to sine squared. So I have negative cosine squared over sine squared, which would be cosine over sine is cotangent. So I see a negative cotangent. I'm happy with that. Okay, here, let's try this one a different way. Cosecant, I can split my numerator, and so I get cosecant squared over cosecant squared is 1, minus this becomes, 1 over cosecant squared. The reciprocal of cosecant is sine, so this becomes minus sine squared. 1 minus sine squared, we just said, was cosine squared from back here. I'm telling you, if you know this identity, life is easier. Well, PreCal is easier. Okay, so cosecant is 1 over sine. Sine of 2x is 2 sine x cosine x. And we have sine in the numerator and sine in the denominator, so we're left with 2 cosine. Oh, this one's fun. This is the sine double angle, but this is a cosine. So let's see. The difference comes down to, this is just kind of, are you even paying attention? Hopefully you recognize that this is kind of a ridiculous answer choice, so don't pick it. This one would be using the sine double angle. And so with this one, we just have to remember which is positive. Is it, because this is 5 times, well, it's 2 cosine squared theta minus 1, which gives me this one. And the other version would have been 5 times 1 minus 2 sine squared. They're just testing to see if you know the formula. It's I don't know how to circle. It's that one, though. Okay, we're getting into polar. Dun, 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 dun. I love polar. I think it's fun. Man, they made us do some stuff with polar I have never done in my life. So that was kind of fun and exciting. He's got a lot of questions here. Okay, I'll start, and then I'll stop in a little bit, but when I run out of steam. Okay, so the location of the point is given. The location of a point in the plane is given by this. So it's r theta. This in polar we do output comma input, which is annoying. But 5 pi over 6 with a radius of 7 is here. So which of the following is another? Okay, so a negative 5 pi over 6 means here. We turn around and give a negative radius. So no. This is pi over 6 with a negative radius would be over here. No. This is negative 7 pi over 6, which gets us to this, and it has a positive radius. Yes, that's the right answer. This is a negative pi over 6, which would be down here, with a positive radius is going to be over here. So, no. The answer is C. Okay, so the polar coordinate pi over 2, 1 is here. Another one, so negative pi over 2, negative 1. Yes, that works. Negative 3 pi over 2, negative 1 is going to put us down here. No good. Negative pi over 2, positive 1 is going to put us down here. No good. 3 pi over 2, 1 puts us down here. No good. I mean, we were right. I was just showing you where the other ones ended up. Okay, so on this one, pi over 3 is here, but we have a negative radius, so we're coming down here somewhere. Which of the following is another? So negative 2 pi over 3 gets me to the same thing, but with a negative radius here, that's no good. 5 pi over 3 means that I go to here and then turn around and go negative, no good. Negative pi over 3, go 2, I'm here, no good. 4 pi over 3, nope, and a radius of 2, that's perfect. Aren't these fun? Don't you love it? Okay, a location here, which the following best describes, oh, in rectangular. Oh, good, we get to do something different. So one way to think about this is 7 pi over 6 is here. We have a radius of 2. So 7 pi over 6 means that this is your 30-degree angle. And so we can do opposite the 30 is half of the hypotenuse. So this is 1, but it's negative. And then, so it's 1 root 3, 2, but they're negative, negative. So the x value is negative root 3. The y value is negative 1/2. Negative 1. I don't know what I'm saying. This is the point. Negative root 3, negative 1. It's this. You could also say, well, it's 2 cosine 7 pi over 6, comma 2 sine of 7 pi over 6. Depends on how good you are at the unit circle. I mean, you kind of have to do unit circle anyway. Cosine of negative 7 pi over 6 is we went over a lot. Negative root 3 over 2. Multiply by 2, we're at negative root 3. Okay, and anyway. Sine of is negative 1/2 times 2 is negative 1. Same idea. Well, okay, not quite, but pretty close. Here's 5 pi over 3, but then the radius is negative, so we're back here. So if this has a radius that's 1, then opposite, and this is my 60-degree angle, so opposite this is the 30 is going to be 1/2, but it's negative, and this is root 3 over 2. So negative 1/2, positive root 3 over 2. Oh, okay. What this one, I wouldn't even bother with sine and cosine. Negative pi over 2 is here, but now we have a radius of negative 4. So where is this point? This is the point 0, 4. Rectangular coordinate is negative 2, 0. Which describes it? If we did negative pi and then we went negative 2, we'd be over here, so that's no good. If we go pi and we go negative 2, that's also over here, no good. This is 2 pi takes us here, and negative, that is good. And then 2, so 0 is here, but with the radius of 2 would put us over here, no good. Ooh, complex numbers. Okay, yeah, I'll keep going. This is the way I like to write it because of what I've taught for years in IB is r cis theta. Because what this means is this is r times cosine theta plus I sine theta. But what PreCal likes to do is say r cosine theta and then plus I times r sine theta. That's fine. I'm just lazy and I can write it really short and fast here. Okay, so negative 3, positive 3 is here. What this is telling us, negative 3, positive 3, this would be 3 root 2 is because this is a 45, 45, 90 triangle. Our angle, our theta is equal to 3 pi over 4, and our r value is 3 root 2. Okay, so this would be a positive x, which is no good. This would be a positive x, no good. Oh, yeah, that's 3 and not root 3. Okay, so 3 root 2, so we can eliminate that one. It's got to be this, but that's what we knew. That's fun. Okay. The next one I think behaves in a similar way, but 1/2 negative root 3 over 2 is down here. Positive 1/2 negative root 3 over 2. So this radius is 1, and this is the 30-degree angle is here opposite that. And then this is the 60. Okay, so 60, what is that? That's 5 pi over 3. And the radius is equal to 1. Okay, they didn't have, oh, okay. 2 cosine. Oh, that's interesting. Nope, we don't want the 2. I think it's just this. It's not pi over 6 or negative pi over 6. So, nice. Okay, so where are we here? What I do, I would say, well, we're here, and this radius is 3. So then this becomes 3 root 2 over 2 and 3 root 2 over 2, but they're both negative. Which is this one. Okay. Where am I? I've been grading and it dries out my hands. So anyway, I have pages and pages and pages that I was grading, and it just dries out my hands like crazy. Okay, so what are we looking at here? We are at negative root 2 over 3 is going to take us this way. We have a radius of 4. And so, well, if this is a negative, the pi over 3 family is, this is a 60-degree angle here. And so if this is 4, then opposite the 30 would be the 2, and opposite the 60 would be 2 root 3, but they're both negative. So negative 2 root 3. Okay, I think I'm going to save these polar graphs for, I'm not sure when. But like, subscribe, comment below, let me know how I can help you, and we will keep going. All right, good luck.